Welcome to our channel Circuits Analytica. In this video, we will discuss a problem on nodal analysis. For the following network, find V1. So here the network consists of 3 resistors of value 5 ohms, 10 ohms and 8 ohms and 2 current sources of value 4 ampere and minus 6 ampere. First of all, let us redraw the circuit after reversing the polarity of current source of value minus 6 ampere. Now let us mark various nodes in this network. So various nodes are marked as node P, Q and R as the reference node. Mark various currents associated with node P and node Q. Let us apply KCL at node P. There are 3 currents associated with node P and the 3 currents are I1, I2 and 4 ampere. I1 and I2 are flowing outwards and 4 ampere current is flowing inwards. So according to KCL, total incoming current is equal to total outgoing current. So I1 and I2 are the 2 outgoing currents. Therefore, we can write I1 plus I2 is equal to 4. I1 is equal to Vp divided by 10 and I2 is equal to Vp minus Vq divided by 5. Therefore, we can write Vp by 10 plus Vp minus Vq by 5 is equal to Vp plus 2Vp minus 2Vq the whole divided by 10 is equal to 4. 3Vp minus 2Vq is equal to 40, equation number 1. Now let us apply KCL at node P. There are 3 currents associated with node P and the 3 currents are I2, I3 and 6 ampere. I2 is equal to Vp minus Vq the whole divided by 5 and I3 is equal to Vq minus Vr divided by 8. So according to KCL, total incoming current is equal to total outgoing current. So total incoming current is equal to I2 plus 6 and total outgoing current is equal to I3. Therefore, according to KCL, we can write I2 plus 6 is equal to I3. I2 plus 6 is equal to I3, where I2 is equal to Vp minus Vq divided by 5 and I3 is equal to Vq divided by 8. Therefore, according to KCL, we can write Vp minus Vq divided by 5 plus 6 is equal to Vq by 8. Vp minus Vq divided by 5 minus Vq by 8 is equal to minus 6. Or 8Vp minus 8Vq minus 5Vq the whole divided by 40 is equal to minus 6. So rearranging the terms, we can write 8Vp minus 13Vq is equal to minus 240, equation number 2. So these are the 2 equations. 3Vp minus 2Vq is equal to 40, equation number 1. 8 Vp minus 13 Vq is equal to minus 240, equation number 2. In matrix form, these equations can be written as 3 minus 2, 8 minus 13, Vp Vq is equal to 40 minus 240. So according to Cramer's rule, Vp is equal to delta 1 by delta and Vq is equal to delta 2 by delta, where delta is equal to determinant of 3 minus 2, 8 minus 13. Delta 1 is equal to determinant of 40 minus 2 minus 240 minus 13. And delta 2 is equal to determinant of 348 minus 240. So delta is equal to determinant of 3 minus 2, 8 minus 13. We will get delta is equal to minus 23. Delta 1 is equal to 40 minus 2 minus 240 minus 13. So delta 1 is equal to minus 1000. Delta 2 is equal to determinant of 348 minus 240. Delta 2 is equal to minus 1040. Vp is equal to delta 1 by delta, that is equal to 43.48 volt. Vq is equal to delta 2 by delta, that is equal to 45.22 volt. And V1 is the potential difference between node P and node Q. So V1 can be written as V1 is equal to Vp minus Vq, or V1 is equal to minus 1.74 volt. Thanks for watching Circuits Analytica. Enjoy learning.